Hello friends, this video on periodic classification of elements part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 6. As I told, a modern periodic table has periods and groups. Let's understand the periods in detail. So horizontal rows of elements in a periodic table are called periods. Correct? For example, this is one period, this is another period. And there are some properties of periods. For example, every period has a consecutive atomic number. For example, this is 11, this guy is 12, this guy is 13, 14, 15, like this, right? So the elements in this period will have consecutive atomic numbers. Also, the number of elements in the period is fixed by the maximum numbers of electrons which can have in the valence shell. For example, the first guy I have not written here, it is hydrogen and this is helium. So they have two. So the first is 2, only 2 maximum elements can happen in the period. The second is 8, lithium 1 is 8, and then we have this guy, sodium, magnesium, this also has 8, this guy has 18, right? So that all depends, the number of elements is nothing but the maximum number of electrons in the shells, the outermost shells. And all the elements in a group has same number of shells because they have similar electronic configurations. And the maximum number of electrons that can be accommodated in a shell depends on this formula. You know this formula, 2n square, where n is the number of shells. Correct? And it is the valence electron which will be the first, and it is the valence electron which decides which guy will be the first and which guy will be the last. For example, the one with the 1 valence electron will be the first, the one with the 8 valence electron will be the last. Correct? Exception is the first one where helium has 2. I mean, you can say that the one with the 1 valence electron is the first, and the one which has all the valence electron filled is the last. We'll see this. First period, if you see, it has only 2 elements, hydrogen and helium, and it's called very short period. See the second guy, it has 8 elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This guy has 8, this guy has 2. It's also called short one. Similarly, the third one, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, it also has 8, also called short. And then we have a long one, that is 18, this guy has 18. This guy also has 18, right? This guy has 32. So it keeps increasing. I mean, there are 7 only. So this guy has the one which is found also. So that's the way it is. So you see that we have different periods. The first period is a very short period, then short and short. Then we have long and long, and then we have very long and very long again. So we have 7 periods, and if you see, this all depends on the 2n square formula, right? It's 2, 8, 8, 18, 18, 32. Now let's see groups. These are all called groups because they have same chemical property. So if you see vertical columns in the periodic table are the groups, and please note they don't have a consecutive atomic number. If you see, it's 9, 17, 35. So they don't have consecutive atomic number as we have in periods. And they have same valence electron, though. You see, helium 2 electrons, sorry, 1 neon 2 electrons, argon 2, or everything has 2 electron valence, 8, sorry. Very sorry, there's an exception here. This guy has 2, but apart from these, all has 8 valence electron. If you see here, everybody has 1 valence electron. This guy is 1, lithium is 2, 1. Sodium is 281, potassium is 2, 8, 10, 8, 1, right? So you see each and every guy has 1 valence electron. So here also, but helium is the exception because helium's cell is filled with 2 atoms. So, but apart from that, all are 8. Here also, if you see, it is 27, this 287, right? So all are 7. They have similar electronic configuration. they show similar physical and chemical property. That is the main reason why they are grouped. This is the first, you can say, critical property. They have similar physical and chemical property. And the number of shells increase as we go down. If you see, this guy has 1 shell, this guy has 2, this guy has 3, this guy has 4. So the number of shells increase as we go down. So position of hydrogen, as I told, right? Position, this guy is placed here because it has electronic configuration similar to alkali metal. And we know that electronic configuration is a critical thing to arrange the elements. So there is no confusion now where hydrogen should be, right? But actually, if you see, hydrogen is a non-metal, the greens one are non-metals, and it is placed with a metal. Right? The hydrogen is placed with alkali, but the property of hydrogen is not similar to alkali because it's very small in size. We'll see the position of metals and non-metals here. So if you see here, all these are metals. All these are metals in this guy. Right, all these are metals. On everything on the left hand side is a metal. So most of them is a metal except this guy. I mean, I can say like this. Yeah. All these guys are metal. Hydrogen and these guys are non-metal. Boron, silicon, germanium, arsenic, these are called metallites, which has metal and non-metal property. But again, that's still debatable. Some people say they are metallites, some people say they are metal, some people say they are non-metal. Again, we'll not debate here. I'm trying to say is everything on the left hand side from this line which I taught is a metal, and on this side is non-metal. Non-metal plus metallite. So we see there are very few number of non-metals and there are huge number of metals. And please note, we'll be covering only group 1, 2, 3, 4, 14, 15, 16, 17. Only these groups will be covering in this class. The other groups will not cover because they're a little complex and they have different little complex way of finding the electronic configurations. We'll study those things in the higher classes, but for this class we're studying only these groups, right? So group 1 has 1 valence electron, group 2 has 2, group 13 has 3 valence electron, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8 valence electron. So we'll study all these groups only, right? So when I'm talking about the properties and all, I'm talking about only these groups in this class at least. Now let's study some trends in the modern periodic table. If you move from left to right, I'm talking about the trends for the periods now, not for the groups. I'll take the groups later. So I'm trying to find the trends in the period, so I have to move from left to right. We see some variation in valence electron, atomic number, valency, size of atoms, metallic characters, chemical reactivity. And we also see variations in nature of oxides when we move from left to right across the periods, right? So we'll go through all of these one by one. The first is the valence electron for a particular period. So what we see is on moving from left to right, the valence electron increase from 1 to 8. For example, if you see this guy has valence electron as 1 because EC is his electronic configuration is 281, correct? This guy, if you see, is 282. So valence electron is 2 here. This guy, if you see, is 283. The valence electron is 3. Similarly, if you see the number is increasing by 1. If you take this period also, it is 1, it is 2, right? So the number of valence electron increased from 1 to 8. That's the behavior we see when you go from left to right. Right? There's a exception in case of my first period, this guy. It increased from 1 to 2 only. It doesn't go to 8. And please note, when I'm talking about these, I'm talking about only the 8 groups which I have discussed, to 1, 2, 13, 14, 15, 16, 17, 18. Because if you take the middle groups, the properties are different, it is complex, right? We're not taking that. We'll take only these groups, and we're assuming that periodic table has only these groups. And then we are talking about the trends. So this guy goes only till 2 and other goes till 8, only for those periods, those groups I have discussed. If you talk about atomic number, we observe that when the elements have consecutive atomic number, there's 11, this guy is 12, 13, 14, 15, 16, the list increases, right? So they have consecutive atomic numbers. If you talk about valency, if you see that the valency increased from 1 to 4 and then decrease, right? So valency is the extra electron which it can have, or it has, or it can take, right? So the sodium has 1 extra electron, valency is 1. Magnesium 2 extra electron, aluminum 3 extra electron, silicon 4 extra electron. Phosphorus needs 1 electron, 3 electron, right? So its valency is -3. This guy is -2, -1. So if you see, it started from 1, increased till 4, again went back to 0, because they are all inert gas and they have valency of 0. So this is how the valency behaves from 1 to 4, then it goes back to 0. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.